In this section, we want to start talking about how we find any absolute extrema for a function. So the question we're going to be asking is there an absolute maximum point, an absolute minimum point, maybe both, maybe neither. So what we're looking for is extrema, meaning again maximums or minimums. So first let's talk a little bit about the idea of a local versus an absolute extremum. So we've already seen how we can use the first derivative to find local extrema. So what we'd be looking for is to construct a sign chart for the first derivative. We would find some point where the derivative is equal to 0, and then we'd be looking for the sign of our derivative to change. So if we get a change from positive to negative, we have increasing to decreasing, so we have a local maximum. If we had it change from decreasing to increasing, we would get a local minimum. So what we want to do is expand on this same kind of idea, but instead of finding a local minimum or a local maximum, we want to find absolute maximums or absolute minimums, so absolute extrema. So our definition for an absolute maxima or minima is that if there's some point f of c, so for some x value, x equals c, our function value is larger than any other value that function ever takes on, then f of c is called the absolute maximum. If f of c, if there is some point f of c, and it's less than or equal to our function value at any other point, then that value f of c is referred to as the absolute minimum. So we're looking for those points where our function takes on its largest possible value or its smallest possible value. So looking at these two graphs, we can get a visual depiction of what we mean by that difference between local or absolute extrema. So our graph on the left, in this case, would have a local maximum because our function changes from increasing to decreasing, and then it's going to change again from decreasing to increasing, so we would have a local minimum. We refer to those as local maximums, local minimums, because once we get past this point, we see that our function keeps increasing above that. So there are other values, other function values that are going to be larger than this local maximum. And since on the left end, our function is decreasing down to negative infinity, there will be function values less than this local minimum. So they're not the overall largest and smallest, but in the region around that point, it's the smallest value or the largest value. Versus the graph on the right, in this case we'll have an absolute maximum, because even though our function continues in both directions, it's continuing to decrease at both ends. So this function value of 4 is the largest value that our function will ever take on, so making it an absolute maximum. What we want to keep in mind is that any given function can have local extrema, absolute extrema, neither of those, or both. So for any function, we might find a local max, a local minimum, an absolute maximum, an absolute minimum, or any combination of those different things. Or it might have none of those different characteristics. We can also see that if we take a graph that doesn't have an absolute maximum or minimum, but then restrict it to a certain interval, we do end up with absolute maximums or minimums. So what we're going to do is consider the graph that we had above, but in this case we're going to restrict it to the interval -3 to 2. So this graph on the left, we're going to restrict the domain to be from x equals -3 to x equals 2. So we're cutting off that graph at those specific values for x, and we've just got a zoomed in view of this. So if we restrict this function so that while initially it continued decreasing and increasing at both ends. Now we have a hard stop where that function doesn't continue past this point, doesn't continue past this point. What we end up with is what was originally a local maximum becoming an absolute maximum. And what was originally a local minimum now becomes an absolute minimum. So we can have different things occurring. We can take a function that doesn't have absolute extrema, but then if we consider it on a restricted domain, we do end up with both an absolute maximum and minimum occurring. So what we're going to do is take a look at how we can use the function that we're given and pull out information about whether or not these absolute extrema exist.